Okay, I think we can just start. So good morning, everyone, and welcome to another session where we're going to continue with confidence intervals. So we already started looking at confidence interval for the population mean, and today we're going to continue and look at how to construct confidence interval for the proportion. So by the end of this session, you should still be able to learn how to do confidence interval for the mean when the population standard deviation is known, when it's unknown, and for the proportion. I'm going to do a quick recap on some of the concepts, and then I'll get to today's session. So we also learned that with confidence interval, we're working with two boundaries, the lower and the upper limit of the confidence interval, and we always use a point estimate, which is your sample statistic, right? And I'm going to skip all of this. And we also learned that confidence interval is also a process of estimating your value of your population or your parameter, your population mean or your parameter. And we also learned that to find the confidence interval, we need to use the formula, which is your point estimate plus or minus your critical value times the standard error. We learned how to find the critical value by using the confidence level. And we know that the confidence level is 1 minus alpha, and alpha is our level of significance. And we touched on the population mean when the population standard deviation is known, and when it is unknown. We know that when it is known, we use the Z critical value, and when it's unknown, we use the T critical value. But also we learned that there are some assumptions that needs to be met for each scenario. So for example, when you're going to find the confidence interval for the mean, when the population standard deviation is known, we use our sample mean plus or minus the Z alpha divided by 2. Our alpha, we would have calculated it from the confidence level, and we will go and find the probability on the table and go look for those Z value, which we call them the critical values, times the population standard deviation divided by the square root of n. And we also looked at how we find the critical values. And this is the other table. For the Z table, you can always remember this table. It doesn't change. But for the T, you need to work it out from the table. So this is a very important table. You also need to remember when you're finding your critical value that there is one critical value that is exception to the rule, which is when your confidence level or your confidence level is 90%, or your confidence coefficient would be or the alpha would be alpha of 0.10. That will have a 3-digit critical value. But you can also memorize this, because usually they like using 90, 95, and 99, where for a critical value for 90 will be 1.645. For a 95, it's always 1.96. For a 99, it's 2.58. And if they give you 98, it can be 2.33, and so on and so forth. We looked at an example. I'm not going to touch the example. We also looked at confidence interval for the mean when the population standard deviation is unknown. And some of those assumptions is that if the population standard deviation is unknown, then you would use the sample standard deviation, or they would have given you the sample standard deviation. But also some of those assumptions that still needs to be met is that your population needs to be normally distributed, and if it's not normally distributed, then the sample size needs to be larger. And we use this formula, your sample mean plus or minus your critical value for the where the population standard deviation is unknown. If we use the T critical value, and to find the T critical value, we also need to use the alpha and the degrees of freedom, and your degrees of freedom is always n-1, which n represents your sample size, times the standard error, which is your sample standard deviation, divided by the square root of n. And because we use the sample standard deviation because our population standard deviation is unknown. And to find the critical value for t, you remember that you go to the t table, the critical values of t, and you look at the values closer to the table under the upper tail area and the degrees of freedom, not the values at the top of the table, the alpha values at the top of the table, but the one closest to the data values within the table, closer to the critical values on the table. We looked at how we find the critical value on the table, and we looked at an example. Now, today, we're going to continue and look at how we do confidence interval for the population proportion. We know that the estimate of a population proportion will be denoted by a pi symbol, and this can be calculated by adding an allowance of uncertainty to the sample proportion, which is our p. And if they don't give you your sample proportion, always remember your sample proportion is your point estimate. If they don't give you the point estimate, they will give you observation satisfying that point estimate, and you can divide it by the sample size, and that will be your sample proportion. Remember, from the sampling distribution, we also learned that for a normally distributed value or your population, it's always distributed with a standard error. If your population is large, your standard error will, if your sample size, not the population, if your sample size is large enough, then we use the standard error as your square root of your population proportion times 1 minus the population proportion. If your standard error or your sampling, if your sampling size is small, then we're going to use the estimate, which we use for your standard error. We're going to use our sample proportion times 1 minus the population, the sample proportion divided by p, and you take the square root of that. So always remember that. For confidence interval, if your population is large enough and they give you, you've got the population proportion, then you're going to use the population proportion. You're going to calculate your standard error using your population proportions. If your sample size is small and they give you the sample proportion, then you're going to use the sample data and you're going to calculate using the sample proportion. So with the confidence interval, the formula will use the sample proportion because we don't know the value of our population proportion. That is what we want to estimate where it is, where does it fall in the lower limit, between the lower limit and the upper limit. So we use this formula, your sample proportion plus or minus your critical value times the standard error. Now, you must remember, for the proportion, we always use a Z table. So it means for when we calculate the population mean or the confidence interval for the mean and the population standard deviation is known, we use the Z table. Also, when we're calculating confidence interval for the proportion, we use the Z table. So let's look at an example. A random sample of 100 people shows that 25 are left-handed. Form a 95% confidence interval for the true proportion of left-handers. Now we need to go back to the question and check what is it that they have given us. So from this question, they have given you the sample size, they have given you the observation satisfying left-hander, which are the observations satisfying that. And they're asking you to find the confidence level of 0.95 minus 1 minus alpha. So we can go and find our critical value. You know how to find the critical value. We have to find our Z alpha, divide by 2 by making sure that we get the value of alpha, and the value of alpha from 0.95 is 0.05. And therefore your Z alpha will be 0.05 divided by 2, which will be 0.025. And you will go to the statistical table and look inside the table and look inside for 0.0250 and go outside and go up and find that your critical value is 1.96. Our critical value is 1.96. So our critical value will be 1.96. And then we're going to use that in our formula. And we know that the confidence interval formula says our P plus or minus our Z alpha divided by 2 times the critical value. So remember also your P, you can find it or calculate your P by using X divided by N, which is 25 divided by 100. I've substituted it into the formula on here, which is 25 divided by 100 plus or minus 196, which is our critical value, times the standard error, which is 0.25 times 1 minus 0.25, which is 0.75, divided by n is 100. We get 0.25 plus or minus 1.96. If I calculate everything, including the square root, I find 0.0433 and multiply with 196 to find my margin of error or sampling error. And I can split the equation into 2 because the minus and the plus, remember the minus is your lower boundary and your plus is your upper boundary. So I can split the same equation into 2 and then calculate. And that gives me, from the minus side, I get 0.1651, and from the positive side, I get 0.349. Or I can write it in this manner. It still says our population proportion lies between 0.1651 and 0.3349. And that is how you would find the confidence interval for the proportion. Now, the other thing, we already mentioned this in the previous session and in this session as well. I just want to also highlight it, that the margin of error is also called a sampling error, and this is the amount of imprecision in the estimate of the population parameter that we get. So you will see that it's the value that you calculate after the plus or minus boundary is the amount that is added or subtracted, because we are adding or subtracting. Remember, if it was for the population mean, it's the plus or minus your Z alpha divided by 2 times the standard error. It is this plus or minus. You are either adding it or subtracting it from the point estimate. So this whole section here on the equation, they will not give it to you in the exam also as well or anything like that. You just need to remember that when looking at the confidence interval formula, only this last part after the plus or minus, it is what we call a margin of error or a sampling error. Also, if this was for the T, you will also use T alpha divided by 2 and the degrees of freedom, and your S divided by the square root of n. And if it is in the proportions, you will only select the last bit of your Z alpha divided by 2 times the square root of P times 1 minus P divided by n. You're only going to take that portion from that formula. So let's look at activities because we didn't do any activity last week. So I'm going to we have to do those activities today so that you can also get some exposure in terms of how to answer some of the questions. So the first one, Africa Check is interested in the activity of fake news tweets. From a sample of 50 tweets, there are 100 impressions on average. Assume fake news tweets activity is normally distributed with a population standard deviation of 25 impressions. What is a 90% confidence interval for the population mean? Now, the first question you ask yourself, what is it that they have given you so that you are able to answer this question? In the exam, they will not highlight some of this like I bolded this word. So it will just be a normal sentence. So, but you need to make sure that you understand what is it that they have given you from a sample. So therefore, already they are telling us that the sample size is 50. There are 50 tweets and they are on average, and we know what average is, right? We learned this from study unit 3. Average means the mean. So from the sample, there are 100 expressions. So therefore, it means this is the 100 that comes from a sample, which means this is our X bar. That's our point estimate. Assume that fake news activities is normally distributed with the population standard deviation. So therefore, it means our population standard deviation is known. And that tells me that I'm going to use the Z critical value, Z alpha divided by 2. And I'm told that my standard deviation is 25. So what else? What is the 90% confidence interval? So there they gave us our 1 minus alpha of 0.9. Therefore, our alpha value will be 0.10 because 1 minus 0.90 is 0.10. So I need to go find my critical value. Finding critical value will be Z alpha divided by 2, which is Z of 0.10 divided by 2, which is Z of 0.05. And going into the table, this is one of those exceptions because I need to go find 0.05, which will be, yeah, so it will be that and between those two values there. So this is one of those exceptions, 1.645. So my critical value, it's 1.645. I don't have to even go to the table by now. If you practice more and you learn from that table, or you make you put it somewhere where you can always go back and reference that table with critical values, then you will know that for a 90% confidence interval, especially for Z, you are going to use 1.96. And I'm saying this because from today to and from Tuesday or Monday, from every time we deal with the Z table, you will just have to know your critical value. So when we do hypothesis testing on Monday, we will still also be talking about the critical value. So you need to know how to find this critical value as well. Okay. So now we have our critical value, but our question was we need to find which one of this is correct by means of making a 90% confidence interval. So we know that our population standard deviation is known, so therefore it's X bar plus or minus Z of alpha divided by 2 times our population standard deviation divided by the square root of n. Our mean, it's 100 plus or minus our critical value, it's 1.645 times our standard deviation is 25 divided by the square root of n, it's 50. I'm going to already work out the margin of error. Just even open the calculator from here and use my normal calculator. Two of them. Okay, so I'm gonna say 20 divided by the square root. Oh, no, cannot be the square root of 20. 20 divided by the square root of 50 equals, I don't have to multiply twice. That's why you cannot use this kind of a calculator. It's gonna mess up your thing. So 20 divided by the square root of 50 is 7,07 and all that number. I'm just going to multiply by 1,645 because multiplication and division have the same priority, so you can work from left to right or right to left or whichever. Multiply by 1,645 and I get the answer of 100. I will have to check that with a normal calculator. Let me use my other calculator to see if I get the same answer. 1,645 times fraction 25 divided by the square root of 50. Nope, I don't get the same. Okay, so something is wrong with this calculator. Let's not use that one. So I get 100 minus, if I work out the margin of error on this side, I get 5. You must let me know if you also get the same. 5,815,9 and some numbers. I'm also gonna repeat it this side. 100 plus 5,8159 and if we subtract 100 minus I get 94. 100 minus 5,8159, I get 94,18. I must leave it in 4 decimal. 1840 or 41 because I rounded off too quickly. I'm gonna have a problem. You must keep all the decimals. And on the plus side, I get 105. 105, 8159. Actually, it's 50. It's 60. 60. So the answer would be, do you also get the same? and there is no response. Yes, Lizzie. Let's look at number 2. The number of times an AI algorithm is successful at detecting fake news is normally distributed with a sample mean of 900. The sample standard deviation of 30, assume that the sample size is 100 was used. What is a 99% confidence interval estimate? Now, what is it that they have given us? They told us that the sample mean, which is our X bar, and they also told us that the sample standard deviation, so it means they have given us S, then population standard deviation is unknown. So this will be our S, and we are given our sample size N. And we also told that our 1 minus alpha, therefore our alpha will be 0.01. So to find the critical value, you're going to say Z alpha divided by 2, which is Z of 0.01 divided by 2, which gives us the Z of 0.05. Is it 0.05? 0.005. It's 0.00. 0.005, and we can go to the table to go find the critical value, or you can use that summary table that I showed you because it's going to be easy and quick. So inside here, we're going to look for 0.00001. We're looking for 0.005, 0.005, but that is more, 0.59. We need to go back, 0.49 and 1. I'm going to take that one because this one already passed with 1. So we're going to use that. We're going to use 49 and go up there and go this way. And the answer will be 2.58. And that is 2.58. That is our critical value. So we're going to say plus or minus. Oh, what did I do wrong? Can somebody tell me what I did wrong? Our population standard deviation is unknown. So all this is wrong. We spent 2 minutes doing something that is wrong. We need to always write the formula first so that you are able to know that you're doing the right thing as well. Because if we would have written the formula first, we would know that we went and found the wrong critical value. So we need to go find the critical value by using T alpha and the degrees of freedom, which is T of 0.01 divided by 2, and the degrees of freedom is N minus 1. Our N is 100 minus 1. Therefore, our T of 0.005 and 99. We need to go to the T table. Can't believe this. We took time. T table, we need to go to 99. 99, and we need to go to 0.05, which is the last column. So we go to the last one. And our answer is 2.6264. 2,6264. So our mean is 900 plus or minus our critical value 2,6264. Our standard deviation is 30 divided by the square root of n is 100. 900 minus, and we calculate the margin of error on the other side, which is 2,6264 times 30 divided by the square root of 100. And that gives us 7,8792. And on the other side as well, we go and say 900 plus 7,8792. And when we solve this, we get on the lower limit, we get 892.1208, and on the upper limit, we get 907.8792. And the answer is option number none of the above. I guess because maybe probably the option given here, they used the wrong critical value. They used the Z critical value to go find this. Oh, they typed something wrong, but it doesn't look like they typed anything wrong. It's just all of them. It's none of the above. Okay. Okay, we're not gonna dwell on that. Let's move on to another exercise, which is the proportion. Mabato randomly selected a sample of 100 children with ASD, found that only 90 of them are in special needs school. What is a 90% confidence interval estimate? So we are given our sample size of n. We are also given our x, not our x bar, our x. So we can calculate our p, which is x divided by n, which is 70 divided by 100, which will be 0,7. And at the 90%, because it's z, you know, z alpha divided by 2, which will be z of 0,10 divided by 2, which is z of 0,0. 0.05, and we know that the critical value will be 1,645, because 90% is that special case. So we're going to calculate our P plus or minus Z alpha divided by 2, P times 1 minus P divided by N. Our P is 0.7 plus or minus 1,645 times the square root of 0.7 times 1 minus 0.7 divide by 100. Okay, I'm not going to do bit by bit. I'm going to use my Casio calculator to calculate this. Okay, so 0.7 minus 1,645 times, open bracket, fraction, not fraction, open bracket, square root, fraction, 0.7 times 1 minus 0.7, close bracket, go down, 100. And the answer is on the minus side, I get 0.6246. 6246. And on the plus side, I get 0.7754. 0.7754. Which option will be option number 2? Happiness? Any questions? No? Good. Okay, let's go look at another question. Now, this is for you to answer now. You must let me know what is it that they've given us. A random sample of 100 results in a sample mean of 100. The population standard deviation is known to be 15. What is a margin of error for estimating a 99% confidence interval? What have they given us?
Sample size, which is the mean, 100.
Sample size of n of 100 and the mean of 100. What else are they giving us?
99%, which is the coefficient, I think.
Okay, so they give us 1 minus alpha of 0.99. Yes, so therefore it means our alpha will be 0.01. What else are they giving us?
Margin of error.
That is what
Standard
we need
deviation.
that is what we need to be calculating. Yes, which standard deviation? Is it this standard
50.
deviation or this standard deviation? Which standard deviation?
Which one did you write first? Sorry, I think the one that you wrote first.
Okay, so what does that mean if it's the one that I wrote first? It's one of the assumptions that you need to know to help you. Because now the next question will be me asking you which margin of error are we calculating? Are we calculating Z alpha divided by 2 times, or are we calculating
I think we're calculating Z alpha.
We're calculating Z alpha divided by 2 times the population standard deviation divided by N. So because the population standard deviation is known, they are telling you that sigma is known and it is 15. So what is our critical value? What is our critical value? We did this and then we stopped it.
2.58.
It's 2.58. Yes. So we're gonna just use 2.58 times our population standard deviation is 15, divide by the square root of N is 100. So what is our margin of error? Nobody knows. You must say if you are not sure how we calculate this.
Lizzie, can you show us on the cashew that 2.58 times over the square root?
Do you have a Casio calculator?
Yes.
Okay, on your Casio, you do have a function that looks like this, right?
Yes.
And next to it, there is a function that looks like this, right?
Yes.
Okay, you're going to use those two functions. So do you see how the equation I wrote where I populate the actual numbers? So you're going to say, these are the steps that you're going to do. You're going to start first by putting 2.58 as a normal number. Then put bracket, open bracket. There is an open bracket somewhere close to the numbers.
Yes.
Open bracket, then press that function that looks like this. After that, then there will be a cursor flicking at the top. You just press 15, it will populate at the top, and then use the down arrow. Use your down arrow to come to the bottom. And at the bottom, when you get there, press this function, the square root function. And then press the number 100. And once you have done that, then press the left arrow and press the left arrow again. And the cursor will be somewhere here, and then press the close bracket. And you will have the answer. Otherwise, if you don't get the answer, press the equal sign. Are you winning?
Yes, I will go and practice it. Thank you so much.
But did you get the answer of 3.87?
Nope.
I thought we were doing it together.
I will go and practice. Thank you.
Okay. No problem.
Lizzie, before we move on to exercise 5, just for my own sanity here, when exactly will I absolutely know I need to use the Z alpha? Is it when they give me the deviation that is known? Or if it's unknown, then I have to go work it out. But then how do I know
No,
I need
you
to?
don't work it out. So they will either give you the population standard deviation or they will give you a sample standard deviation. Can you see there?
Yes, yes.
Sample standard deviation, or they will say from the sample, the mean is this and the sample, the standard deviation is this, then you know that that is from the sample. Otherwise, they will specifically tell you that it's from the population standard deviation.
Okay, so when I have the population standard deviation given, then I work on the Z alpha formulas.
Yes.
When do I work out the T? Sorry, the different
When
DF.
when we are given the sample standard deviation.
When I'm giving sample. Okay. Thank you. Sorry, guys.
No problem. So this is the thing. On here, it's a very tricky question. Can you see? It says the confidence interval estimates below are from the population mean estimated using a 90%, 95%, 99%, not necessarily in order as they appear here. Which estimate must be the 95% confidence estimate? Now, what they are saying here is, assume that you know how to work out the estimates. What they mean is, if 90% is there, the estimate, if this is the boundary that tells us this is a 90%, and this is the boundary that tells us this is a 95%, it might be and it might not be, and this is the boundary that tells us it is a 99%. And looking at this, then it means all these boundaries are different. They are bigger, they are smaller, because this is bigger, this is bigger. So this, if that is 90% bigger, that will be that. If this is the second biggest, that will be 95. If this is the largest biggest, that will be 90. The smallest, that will be that. Now we need to figure it out. And figuring it out, it will be in this manner. Because we don't know all these values, how they calculated them and all that, we can make for ourselves fictitious data. And by that, I mean, I'm going to use 99, 95, and 90% with my dummy data. So I'm going to assume that my mean is 2, my standard deviation, I'm going to also make it 2, and I'm going to make my n, I'm going to make it 4, right? Because this is just a fictitious data that I'm going to work on. And from that, I'm going to place the values I get for each, for 90% and all that. So for now, I'm going to remove all these things that I wrote there. Let me remove them and write it here. Because I don't know which one is which, right? I'm still going to build it up. So I'm going to start first by 90%. I know that for a 90%, and because they say it's for the mean, and I'm going to assume that I've got my population mean, so I'm going to use the Z-score that is easy for me to recognize. I know that for a 90%, it's 1,645. And then I'm going to calculate for a 95, and then I'm also going to calculate for a 90 and 99. For a 95, it will be 1,96, and for a 99, it will be 2,58, right? So those are my critical values. I know that. So let's go and calculate. And we're going to use the formula X plus or minus Z critical value times your population standard deviation divided by N. So that is the formula that we are using for all of them, so that then I can build it up from there, so that I can use these values, right? So I'm gonna show you an example, and then I'm gonna transfer those values also onto here. So let's start with 90. So this will be 2 plus or minus 1,645 times 2 divided by square root of 4. So I'm going to calculate the values. Just use and calculate here. 2 minus 1,645, open bracket, fraction, 2 divided by the square root of 4, close arrow, arrow, close bracket. And then I get 0,355. That is 1. On the plus side, I get 3,645. Now, the only thing I need to change here is the critical value, which is the 1,645. So I'm going to use 1,96 and do the minus side and the plus side. So already I've got the plus side, which is 3,96. And then I'm going to change and do the minus. And I get 0,04. And then I do 2,58. And then I get minus 0,85. And then on the plus side, I get 4,85. Now, I'm gonna take these values that I just made up. I'm gonna put them on the scale. Let me redraw them again so that I can paste them out nicely. So at the top, I'm gonna use my example. At the bottom, I'm gonna lay out these values that we have here. So let's look at each limit. So this looks like a bigger limit. So therefore, it means this is a 99% confidence level, right? Because it says it's minus 0,85 until 4,85. The next one is a 95% because it says it's from 0,04 and 3,96. You can see that they are still within those limits, right? And the last one is a 90% limit, which is from 0,355. It is inside the 0, because it's bigger than that, but it's smaller than 3,96. So it's 3,645. So by doing this, I already now know that the limit where it's bigger, it will be a 99. Where it's second biggest, it's 95. Where is that? So let's look at these values. So this says it's from 163 to 236. So it means this is big. So this is 163 to 236. And within the 163, there is 176, or 72 actually. 172 will be somewhere inside. So that will be 172, and 272 to 227 is lower than 236. So it will be here 227, and 176 is somewhere here. So this will be 176, and 223, it's lower than 226. So this is 223. So already I have my answer. Can you see that? Which estimate must be a 95? the estimate that falls within 172 and 227. So you can work it out that way, but you also can work it out by understanding that the bigger your critical value, the bigger your limit will be. The smaller your critical value or your confidence level, the smaller your confidence limits will be. Right, that is the other way of answering that question. And I think we are over time in 2 minutes, but I do have additional exercise that you can also do. So you can take a picture and do it on your own. So yeah, they're also giving you population standard deviation. So you will use Z alpha divided by 2 to construct that. And exercise 7, they say a survey is based on this, and you can see if you read this question, it says a labor survey based on the sample of this in an urban town found the average salary of the urban worker to be said to be, or is said to be 3,500 with a standard deviation. So because the sentence is 1, then it means this is your sample mean, this is your sample standard deviation. Therefore, it means your population standard deviation is unknown for this one. So you will use T alpha divided by 2 and the degrees of freedom, which is n minus 1, to find the critical value on this one. The next one, so you need to be able to read the question and make sure that you understand which one are they giving you. Is it the population or the sample standard deviation? The next one, they explicitly told you that it's a sample standard deviation that they are giving you. So that makes it easy for you to calculate. You will use T alpha divided by 2 and the degrees of freedom of n minus 1. The last one is proportion. And they are telling you what your P is. You don't have to go and calculate your X. They're already giving you your P in the right format. So your P is just 0.48. You just go and substitute into the formula and find your confidence level. You need to pay attention as well. Sometimes they can trick you. What is the upper limit? There is the minus and the plus. Remember that if they ask you for the lower limit, you calculate only the minus side. If they ask you for the upper limit, you calculate only the plus side. So you will use Z alpha divided by 2 and your P times 1 minus P divided by N plus your P. That will be the formula that you will use to answer question number 10. And on that note, that concludes today's session. Are there any questions? Any
No,
comment?
thank you. No, thank you.
Yeah, on that note, then still likewise, we from Pambili Analytics, and I'm not going to even bore you with my speech today. I just want to say thank you to all those who are subscribing to the channel. Keep on subscribing, keep on sharing. Those who are our members, keep on supporting us. We appreciate you. If you want to receive the recordings of all the sessions and the videos and the notes, you need to join our YouTube membership, and especially on those 3 levels, so that you can gain access to the recordings. Otherwise, thank you to our loyal supporters who always constantly put us first by supporting our content and also the channel. Thank you very much. We appreciate you. If you want to get hold of us, these are our contact details. And have a lovely weekend.
Thank you, Lizzie. Goodbye, all.
See, goodbye, guys.